Good morning, mathematicians. This is Mrs. Shopper coming to you with the start of Unit 6. All of Unit 6 is going to be about slope. You talked a little bit about it in the spring last year, but we're going to make the assumption that really we're just kind of starting over fresh, okay? So when we talk about slope, what we're talking about really is rate of change, okay? We're talking about the change in your dependent variable compared to the change in your independent variable. Okay, so rate of change could be, let's talk about some possibilities. Rate of change could be miles per hour. Rate of change could be apples per pound. A rate of change could be dollars per hour babysitting. Rate of change could be your points per game. Okay, a rate of change could be your miles per gallon. A rate of change could be students per hour. All right, so there's a lot of possible rate of change. You could talk cubic feet per minute. That's something they talk about with HVAC systems. So there's a whole bunch of rate of change that you can be talking about, and it's all around us. It is all around us. So what we want to do now is start talking about what are the different types of slopes and really how does that work, okay? So we're taking a look at these couple charts, okay? One shows drive time and one shows cell phone information. So if we want to figure out the rate of change in this table, it's going to be the change in y divided by the change in x. The change in my dependent divided by the change in my independent. All right. So we're going to take, what I can do is take 76 divided by 2, or 152 divided by 4, or 228 divided by 6. And when I do that, I'm going to get what my rate of change is. So if I do 76 divided by 2, I'm going to get 38 miles per hour. 38 miles per hour. And what that means is for every hour I travel, I'm going to travel about 38 miles. With the cell phone table, okay, this is a little bit archaic. When I first got a cell phone, we got charged per minute. Can you imagine? Can you imagine if you got charged per minute with your cell phones now? Crazy idea. That's how we used to do it back in the good old days, right? So here we go. We have the cost in dollars per minutes used. Again, we want to use that change in y divided by the change in x. So if my cost is $1 for 20 minutes, okay, or 2 divided by 40 or 3 divided by 60, if I take 1 divided by 20, I'm going to get 5 cents per minute. So my bill is going to be 5 cents per minute, right? So every minute I talk on the phone, it's 5 cents. Okay. Now I recognize that a lot of us don't probably talk on our cell phones. We do a lot of texting and Snapchatting and so on, but can you imagine if each of those were 5 cents? All right, something to think about. All right, we can also look at a graph to figure out your rate of change. When I take a look at this, there's 2 different rates of change. I've got this part and this part. So when I look at this graph, we want to find the rate of change from 2002 to 2004. So when I look at this side, it says that's the number of passports in millions. That's important. We want to make sure we're looking at what it is. It's in millions. So we're going to take 8,900,000 minus 7 million, because it's the difference in those two numbers divided by the number of years, 2004 minus 2002. And again, this data is pretty much 20 years old, so 15 years old. So it's a while ago, but it's nonetheless, we're still finding our rate of change the same way. We're taking the difference in our Y's divided by the difference in our X's. So we're going to figure out that we've got 1,900,000 passports per 2 years. And when we're doing rate of change, we always want to make sure that it's in simplest form. And so I'm going to take 1,900,000 divided by 2, and I'm going to get my rate of change to be 950,000 passports per year. Excuse me, per year. All right, so I'm just going to shrink all this down. We're going to bring that right on over here. Okay, so from 2002 to 2004, that's my rate of change. It's going to be 950,000 passports per year. Okay, per year. That label is important. It's really important. Now, from 2006 to 2004, we've got 12,100,000 minus 8,900,000. Because again, our passports are in millions. It's important to write that number out. And that's going to be divided by 2006 minus 2004. So it's a difference of 2 years. I just realized I'm missing a couple of zeros over here. And so I'm going to have 1 minus 8.9. So 3,200,000 passports over 2 years, which when I divide that out, I get 1,600,000 divided by 1. So it's 1,600,000 passports per year. Okay, so we're dividing those numbers out. You're taking the change in Y divided by the change in X. Okay, we'll put those over here. There we go. Okay, and then our meaning in each of those really is our label. That label helps us out with it. Okay, here's another graph that shows you that information. Again, we're looking at the difference. This graph is linear. That means the whole thing is a straight line. Here, we notice that the rate of change changed. It was a little bit steeper for the second part of that line, whereas here it's the same. And so these are the number of airplane departures. Okay, and again, it's going from 95 to 1,000, 1,000 to 500 to 05. So I'm going to take 9 million. Again, I'm looking at my side to know my label. It's in millions. So 9 million minus 8,100,000 divided by 5 years, because from 95 to 2000 is 5 years. So I end up with 900,000 flights over 5 years. And if I take 900,000 and I divide it by 5, I'm going to get 180,000 flights per year. That was the increase. Okay. It went up by 180,000 flights per year. All right, a couple more before we give you some time to work. This is applying it to real life. Again, we use this all the time in real life, okay? So a realtor estimates the median price of an existing single home currently is $221,900. Median means it's the middle, half are greater and half are less. 2 years ago, it was $195,200. So over the course of 2 years, the price increased by $26,700. It increased. So if it increased at the exact same amount each year, then we're going to say that that house increased annually. That means per year at $13,350 per year. Okay, so we're taking the difference in the amount divided by the time that it took. If time is ever an option, that's going to be your denominator. That's going to be the number that goes down in the denominator. Okay, how about the space shuttle one? The space shuttle achieves orbit at 9:23. At 9:31, it's already traveled 2,309.6 miles. We're going to find that rate of change in miles per minute. So miles per minute. Okay, so the miles it's changed is 2,309.6. The time it took is from 9:23 to 9:31. The difference in that time is 8 minutes. Okay, 8 minutes. So I'm going to put an 8, put an 8 down here. Okay. Now we want to know per minute. So I'm going to take that amount. I'm going to pull up my calculator and I'm going to do 2,309.6 and I'm going to divide it by 8. So $288 or dollars. Goodness gracious, shopper. Miles. 288 miles, 0.7 per minute. This is miles per minute. All right, here we go. I'm going to actually get you started on your homework. If you've got more questions, let me know. The video is getting a little long. So this is going to be your assignment to work on now. Thanks much. I will see you all real soon. Take care. Bye-bye.